This is Riyaz Sheikh. I'm a principal data scientist. I work with multiple companies, startups, and enterprises for building their AI application. I started my journey as a tester from Mulya. So since inception, I'm aligned with basically Mulya and the people. And I changed or basically want to learn a lot of things. And I get attracted to this data science since 2013, 14 around time. And I'm working in this field in this, from around 10 years now. So I build a lot of AI applications in banking, healthcare, manufacturing industry, computer vision, a lot of stuff. And what I found is there is I actually failed a lot of when I started as a data scientist because in the earlier period of data science there was a lot of hype and everything then, and everybody wanted to do something into data science, into machine learning or AI. Everybody wanted to be in an AI, and I was hired by some organization then, and they asked me to build AI, and we failed terribly then. And all these failures, I start to learn, that how to overcome everything one by one. And then I think at this stage right now, I wanted to give it up uh, to the lessons that I have learned while building AI applications. And the reason that I chose this particular topic is most of them, even 99% of the projects of AI failed, even though there is a lot of hype. Not all the projects are get successful. In the traditional software project, I think there are 70% of the project fails, but in AI is quite a lot. And the most of the reason is testing, because they are not being tested, in a really good way, or people don't know the way that they should how they should be tested. Okay, and that is why I'm here today to tell you few things about how it should be tested, how it should work there. If there is any data scientist with us, let us know. It will be really helpful to see their comment too. All my all the this one particular session, make it into one particular slide. This is the slide that I wanted to tell, that if there is audience from outside India, they will not be able to much relate about it, but probably, but this is about the slides tell that being atmanirbhar or self-sufficient doesn't mean the data scientist should test. We still need a tester to test it, and we the testing community has been telling this particular idea from last so many years, but this is really relevant to right now into machine learning or AI stuff, and we really need a tester that can test AI. So today we are going to learn three things. So I divided the whole session into three parts, and we are going to learn one by one each of three. I think we will give like 15 minutes for each part, and in between we will have small questions to understand whether where if we are if this topic is helping you to learn few things. So these three topics are, first is we will learn why we are going to test the AI system. The second topic is about the challenges of testing AI. We will understand few challenges of testing uh, AI system particularly. And the third topic is the framework that we built into Mulya for testing AI. So we have worked or researched a lot of this particular thing, and we have built some frameworks and some mind maps. Like testers love mind maps. The mind maps around it, and to teach or to processize whole thing, so that we can test really the apps of which has AI element in really well, so that we will have certain confidence that we should deploy it or we should productionize it or not, right? We will see that at the end. So I have few projects that I did personally on myself. I built it, and I encountered few failures while doing it. So there are two projects that I'm getting it into the session, and two more that are quite popular into media that I'm going to do it now. The first project I did is with for one of the banks. They wanted to build a really good AI system which will predict that if their employee is going to leave or not. Usually the companies spend a lot of money to retain their employees, keep the best employees, right? And when they leave, usually the best people are the ones who go first, and when they leave, there's a lot of loss to the company. So they wanted to understand whether they can predict it. And so when we build a model using employees data and all, we our the first model, the first application has a 95% accuracy, which is a really good number to have, right? 95%. Usually we see it's a big number. when we see when we saw that out of 95%, what exactly the results are. So there were like 8,000 employees, and each month around 40 to 50 employees leave. We were telling that, hey, take this 500 employees, and they are going to leave. Okay, and that created havoc in the system. Like, oh, 500 employees have a chance to leave. Then everybody started, doubting each other. Like, or basically HRs or the managers say, okay, this person might leave. So there are total 500. So our model is not really great in predicting. Out of 500, uh, of course, there are probably some people, 40, 45 people are going to leave, but what of about other 450 people? They are not going to leave, but still we are doubting them that they are going to leave, and that might create a bad impact on the system. So this is the first failure that we occurred. um, Second project that we will go with. This was one of the project I did with Germany, one of the manufacturing company, and this was about a predictive maintenance project. So what happens in predictive maintenance is, this is really good thing to learn. There are machines and all those instruments that does their work in a regular basis. But when they fails, they have to we have to maintain them. We have to do certain maintenance activity. And if we add sensors there, nearby there, so that we will get to know the pressure or temperature or the other all of the parameters about them when they are running and when they are failing, we can get the conditions why when they are failing. So my model, when I build the model, I try to understand at what part the machine can fail. So there are really big machines, like a few like hockey ground, and these kind of bigger size of the machines are. And there are like 400 500 different sensors sending me data to my database for each second. And there are billions of data rows that are available, so that I can analyze them. And there are very few failures. Like in even though a machine failed, the failures is like very less, like 8 or 10 times in a year. And and they were not happy with that. And the failures were occurring randomly. So I wanted to predict it, that when they could fail. So when I built my model, I had really good accuracy. But later on I found that I have total 100 prediction. And I saw that there are only 8 or 10 times it fails. There 92 times it was false positive. So I'm telling them 92 times that it is going to fail, and they were running around solving the problem when there is no problem. So these are the situations that occurs. These are called as false positives in technically into the data science field. So I'm going to show you some very popular examples that we had, where we saw actually. And you can also reference it later on. Was quite popular into inventions through IBM Watson into AI, and they have built a product known as IBM Watson for oncology, so predicting cancer. What a great problem to solve! And predicting or the telling the patient that what kind of medicines you should take, or the prescription, basically giving to the patient. So that's a really great problem to solve. But when they launch it, they failed badly. And in all the media, they start accusing because of the failures of the software. And when the people we found out that data that they have used was quite hypothetical data, and they didn't use the real patient data. It also happens that sometimes the hospitals who deployed this system, they found that the patient who had bleeding problem, and when they got the prescription that to solve what medicines they should have, we found that the IBM Watson is telling us to take a drug that will worsen the bleeding. So this is the life threatening issues that AI can do if we are not properly testing AI. So this is just a testing problem. If we can see or we can understand, this is just a testing problem. This was quite a popular example on Twitter. What Microsoft did is they built a chatbot, the automated bot, which will have over their his own handle, Twitter handle, and tweet or try to socialize people. And within 24 hours, the the bot name as Tightwits has learned to be racist and racist within 24 hours and try to tweet to the people. You can see there are certain slides. You can see in the slide what they tweets are tweeting and what people are talking about them. It was a big failure. Microsoft took it down within few hours, and it was a very bad example. Even though there are really good examples of AI, there are bad examples too, and we need to identify why they are failures, so that we can be a better tester of and we can we can support organization building a better quality app. So we are going to see a little more about AI systems and the challenges behind AI systems in the next 15 minutes. The AI, if you look at the 30% part of it, I would say more than 30 to 40% part of it, if it should work into the whole application that you are going to build. There are three dimensions that is being added. Usually, your application has data and the code, but AI application has data not to support the application, but to run it. So the data is more like an actor than just a storage here. So data decides the model. Okay, and what model is, what exactly the model is, like people talk about what this the model, we need a model, but model is just a simple binary file sitting into your application somewhere into the folder. It's just one single file. Okay, and what it has inside, if you go inside, look at it, if we get a chance, there are lots of conditions written. Okay, nobody just can put it write those conditions, because they are very encoded into binary format, and they change a lot. But the model is just one single pickled binary file, if you understand the programming. And we need to test that change a lot. The data changes, the model changes. And what the third part is a code, the third dimension, which is about how you will run the model and when it should be, when it should predict, or when it should not predict, or whether it's a real time or it is a batch processing, all those things. Now we will talk a little more about technical depth of AI system. Yeah, you can hold. uh, so this particular concept about technical depth is quite popular within the software community, because each of the programming language or each of the databases or anything that you choose comes with certain depth. So we were talking about technical depth. Any system that we see, any system that we build, application that we build, comes with certain depth because of we chose certain technologies to build it. Each database that you choose, each programming language you choose, or the infrastructure you choose, everything comes with certain depth. The AI system too has certain depth. This is very popular actual concept to understand before building any kind of system, because when you before starting project or the product, you choose certain language to build, or certain infrastructure, certain database to build. So same thing for AI. If you need some really good real mission critical AI systems, you need certain different kind of technologies than the something like recommendation system or chatbot. So you have to choose where programming language of code or the model very carefully, type of model very carefully. Now, technical depth means there, if you choose a system, it comes with certain issues with it. And three things that I'm going to highlight right now. The first thing is about a little complex to understand, but complex models erode boundaries. So when in the traditional software development, when we want to build models, or sorry, not models. In the traditional systems, when we want to build code, we usually write in a very modular way, or the segment the code in, so that concept like encapsulation and all those things that will help keep my code within the boundaries. Okay, it is really not dependent, and it works smoothly. But AI systems, it is really difficult to have those boundaries. And because it's very simple, we cannot just assign the boundaries, because data is something that is controlling everything rather than your logic. The second depth that we have is a case that we call is changes anything, changes everything. It's really important to understand this concept. In AI, if you change one thing, it will change everything. For example, you have data, and you have data of like a structured database, and in the database there are like columns, like 100 columns, and if you just remove one column next time while training the model, because you just found that it is not relevant anymore, it will change whole prediction, it will change completely everything. It will, your model will have completely different logic behind the predictions now, and the results are going to change everything. If you just, for example, introduce new column, introduce new feature, it is going to change everything. If suppose the context is changed, the COVID-19 comes, the pandemic comes, everything changes. Even in the retail, any recommendation system running on the retail, the media that in the TV, if you saw some advertisement, or anything that is works on via AI, predictions is going to change a lot. Then there are third things about hidden feedback loop. What means is, uh, even though we see there are two systems which are completely independent, but in the real world they are dependent somehow. Let's take an example. There are two investment banking companies, okay, and they do a billions of investment to share market. Okay, two completely independent, and they have two algorithms running in behind to understand, analyze the market, and see when, give the prediction recommendation, which company we should invest it, or the delist, or the remove their investment, and all those things, all those decisions AI will recommend, and it will quickly run it. Because we usually in the market, share market, we don't have time to understand and run it and tweak the button. It will take few seconds, but this AI application run in within microseconds or the nanoseconds even. In fact, they are so lightweight applications. So if we take an example of two independent companies, suppose one AI A is going to change or start giving the wrong results, the AI from the system B or the company B is going to observe that, and going to start to analyze why investment company A is doing certain investment, or and try to make its prediction in a certain way that will not impact the investment of B. Okay, so even though we see that okay, these two are completely different systems, they are going to change. They are going to basically impact each other, and these are called as hidden feedback loops. There are so many feedback loops we can analyze, and we need to identify them while testing the AI system. Challenging, now we will come to the basically challenges of testing AI. So there are like 6 to 7 challenges that I found myself while building testing teams into AI. Yeah, next. So okay, the first challenge that I saw is a very important challenge to understand. The data scientists that are working with you are not programmers. They don't understand loops. They don't understand probably encapsulation. There will be a less chance to do that. What they understand is statistics and models. They just build some models into their notebook and give it to them. Okay, do whatever you want to do with it, and probably it will be very hard situation to understand that how they can build, and when why how it can be built further into an application, because uh, some there are industry is going to demand that data scientists should build their application completely themselves. Okay, so it's very hard for data scientists to come from that native notebook environment to a very ID specific environment and build a programs which are efficient. Okay, and data scientists are usually not programmers, so you have to understand that, and you have to take care so that while building a program, they are not introducing any errors or memory issues or those kind of programmatic issues, right? And to write a modular code is something that is a challenge for data scientists usually. Things are changing right now, but still, most of the times, like 90% of times, data scientists usually do mistakes of a new programmer. Second challenge is about a tester would hard definitely to find how to test without knowing ML. So a tester without who doesn't have idea about how ML works, probably it will difficult for him to understand how it should be tested too, because in the traditional system we have certain rules to basically gauge or validate our results, but in AI we usually don't have. We have the real world or the users who are going to validate, and that's very not a really good situation to have, because we have to deploy it and see whether our users are going to react with our application. Third thing is about adding into a newly expensive project. Okay, the data scientists are too much costly these days. The cost is going to be lower soon, but it is still expensive. So when I saw there are CIOs, when they started funding the AI projects, what they think about is cost of data scientists. That's it, nothing much, nothing more, nothing else. So they will hire data scientists with giving them really good salaries, but they don't think about the testers. And when we comes time to understand the quality, they usually rely on data scientists to tell them what is the quality of my AI, which is very bad, because the developers, even though they can really have a really good idea about the AI system, we need to have certain third user to understand the quality of application. That's where test comes into picture. Fourth thing is about the culture behind of the organization towards the testing, which I saw really important thing to have is I work with few companies where there are like 50 developers into one project, but only one single tester who is testing the system. And what he is doing is just writing some test cases and just passing it, and not even failing it, because they had very strict deadlines of development, and all the timeline that is given for the testing has been eaten by development, and this culture actually impacts the quality of testing a lot. So organization needs to understand that we need a tester, so we need to give them a right amount of time. Yeah, for starters, we can project, we can introduce them from the phase where the model development has completed, and not in the stage of alpha or beta testing. Okay, so that's a really important thing to have. The last is about few guidelines and success examples. There are few examples AI works. You don't encounter every day the people who have built a successful AI, and they will share the examples, because there are very few examples already having a successful AI. Not all the AI projects have been successful. Most of them are failed, and they just switch organizations trying to make next thing perfect. And that is why there are few guidelines and success examples, and that is why it's very hard to gain knowledge, and that is why we are here today, so that we can build a community and try to gain knowledge about each other, about building systems, and build a really good processes about quality testing of AI, because this thing is going to be huge in the future. Okay, so there are five aspects that you need to test when your AI system comes to you for testing. This is the first thing about the tools that you are going to test using it. Then there is a monitoring part. AI needs monitoring in the real time, because how it is going to give the results. Then there are models, the models that I told you about, the binary files. Then there is an infrastructure that is used for basically building the application, just like any other infrastructure that you have. The cloud environment and those backend and front end on those things that needs to be tested. Data and features, is your data sitting into your data warehouse, or the ES3 bucket, and the features is basically the column of the data. So don't worry about this particular word. Feature is just a column. So I built a mind map for within the internally, and it's basically going to evolve. As you know, mind maps are really helpful for structurizing the thoughts of the tester and what things to be tested or not. So we build a mind map around the four parts right now. One is the data and features, then is another is the models, infrastructure, and monitoring. For data and features, what are the tests that we are going to have? So, for example, some tests like data pipelines, privacy controls like GDPR, and those kind of things that needs to be tested for data. In the because in the you will see that if you look at the code of AI, you will see 80% of the part is about just data engineering part of the ETL process. Okay, nothing much. Okay, only 20% of it will be the model training code. Okay, which is really so that is why you are going to understand when you look at the AI code, you will understand it quickly because 80% of part is just familiar. It is just the data wrangling thing, data engineering part, ETL process. Data schema in variations, which is our tabular. If it is a tabular data, then it's basically how each columns and mean variations of each variant. For example, in one data set, the male to female ratio is 50-50, and suddenly you are in the real world and you are encountering like 70-30 or 80-90, 80-20, then you will find that there is a variation going to happen. This particularly happens into hiring kind of applications where even though we teach models to don't be biased, but in the actual world, in the for example in the development field, males are going to apply much than the females, and that is why model starts to learn that males are going to be successful into development. So, and that is why there are certain failures too. From like Amazon also built a system which fails. Then we need to understand how new features can be added or new columns things can be added into data. We will go to the models part here. Model ML fairness tests. These are about understanding how model is fair towards the law that the country has been built. This is very important because certain law we have to other certain laws of the country about the fairness, and that needs to be there. Into we can't EML model can't be racist. ML model can't be biased towards certain community, religion, or something like that. It should not be do that. If it's doing that, it has to give certain warning before giving the result. Okay. Then we have model specification undergoes a code review. This is very important. How frequently the model needs to be retrained. Model if is model too old. This is the model staleness problem which I had talked about before, which is model gets old. uh, Suppose you have 5 years of data, and on you have out of that you have trained it on last first 3 years, and you are predicting on next 2 years. You have a model that was 2 years before, it is older for 2 years. Okay, so that is why you need to make sure that a model is trained on the right data. So what you can do at those times is take the sample of data, and that samples to it should be throughout the 5 years. And okay, okay, so those things that needs to be taken care. And you can ask this question to data scientists with the models too. I have a blog, AI testing blog, which I have shared. I will share the links after the presentation, and you can find more about model stainless or the AI testing part there too. Monitoring part is important. Monitoring is about how the model are behaving or in the real world, and whether we need to train the model again, update it, or just quickly build a new model from scratch, and all those things. And then monitoring needs to be there in form of real time charts or something, or some analytic system, so that you can basically analyze model how model works in the real time. In the infrastructure part, we have to understand how the deployments are happening, how the testability is. Basically, do you really able to see the model results and quickly, rather than going through the whole sequence of model training and all. But is the model really testable or not? Basically, it should quickly tell us results and tell us, or we should not keep it should not keep us waiting to see the results. Model quality is validated before serving. This is really important. Understand that suppose you have 5 years of data, and you will use 80% of the data for training the model, and 20% of the data which has model has not seen, to test or to validate the model, what is the accuracy of it. And you need to make sure that it gives a good accuracy both in training and both in validating, and then you can deploy it in the real system. Then we have reproducible results, which is really important thing to test. What it means is, today for me model is predicting that I'm going to leave the organization, but tomorrow for me model is telling that I'm not going to leave the organization. So model results are changing for the same type of person or same type of data points, which is really should not happen, and that should be tested, because that actually happens in the system, and which is a really big problem to solve at the first itself. Okay, so this is the AI testing mind map. You can definitely ask questions about this. So you see, in the mind map I have given certain questions about each of the part. These all things can be judged and given certain score from 0 to 5. 0 is basically just a research environment that model or data scientists use, and the 5 is just basically exception level of automated testing. Okay, and you can give them certain score of each part. For example, usually the enterprise try to be at the score 3, because that's really enough stage to have, because the more after 3 the cost of testing increases exponentially. Okay, the one is something that is just tested for unit tested but not integrated testing. I'm going to show you some charts here, that how our monitoring of the all testing works. We have built a charts where for each of the point in testing, we're identifying what is the average score of the each of the part, and we try to take almost near to 3 for each of the point into the mind map, or the testing test case into mind map. So these are the charts that you can create. You can use Google Data Studio for that if don't want to spend into too much into the analytics tools or BI tools.